So it is now my pleasure to kick it over to Stu. It is all yours.
Hey, Kevin, thanks. You know, in the next intro, one very kind thing said was that, hey, Stu is the Stephen King of tech writing. And I thought, hey, that was a kind thing to say. So, hey, if you're here to learn 5G practical slicing, you're technical and you want to know what it really is. What is all that stuff behind the curtain? And that's what we're going to cover. What is it really? And what could I use it for that once I actually understand what it really is? So let's start out with the very beginning. The assumption is that you start with a very large private network. Now, emphasis on private. Theoretically, you could build this over the internet, but then you really wouldn't be doing slicing, because slicing requires that you have control of the entire network, all the way down to the routers and switches. The connectivity that goes between all those, that's all yours. So that means that that's going to be large telephone companies, cable TV companies, ultimately anyone who can run a really big network has the beginnings of creating slicing, because it's on top of this network that we're going to build another network. So it's very important that you understand this. And this is a classic starting point that I think is often missed when we're trying to understand what slicing is. If there isn't an underlying IP network that's privately owned, you can't do this. Not sure where that fine print is missing all the standards, but it is important that you understand that. Now, the next thing is you'd say, well, okay, on this network, which let's say that the phone company is us. This is our phone company and we own it. So what we're thinking is that we're going to put this edge service in central Pennsylvania, where that big blue arrow is right there. So that means this is an IP network that is connected through a gateway to this underlying network. Now, just having one point is not interesting. So let's add a second one. Sorry, guys. I guess I'm going to have to unplug some phones. And we're going to take a look at the 5G network as we connect to our underlying network. So this little blue circle right here is the underlying network. That's this right there. On top of it, we're going to place a user plane function. You could actually think of this as a VPN gateway, and it would be very similar to what's being done in 5G and very honestly what's done in 4G. In fact, in 4G, you would refer to this as a PGW or an edge PGW perhaps. On top of that is a 5G subnet. In 4G, we would have called that an APN. But in 5G, that's a data network name. And we could almost stop right here. We could almost end the webinar right here and say, practically, the purpose of this is that I can make this anywhere, anytime, any place. I could make this just for some private company who wants their own network connected, because you could put your own subnet, like this would be your corporate connectivity, and basically you would carry a VPN access around in your 5G phone. And the advantage of that is that effectively artificial intelligence is in charge of managing all of this. So if you understand the 4G network, you have a huge head start, because this would be the PGW to you, the packet gateway, and this would ultimately be the data network you're connected to. The difference is there's a lot of manual work to set that up. In 5G, we want to make this completely auto magic. And by the way, when your phone connects to the network, it will be given an IP address in this range. Okay, let's continue. So if we actually take a look then at how does our phone, our user equipment actually get connected to here and then continue on to surf the internet? Well, this is where that private network comes in. So we have our phone connected through a G node, a generational node B. You can think of it if you want as giga, but the G stands for generational, not gigabit. But if you want to think of it like that, it's more interesting than an E node B, which would be the 4G equivalent. All right, so I consider this then as radio, but the rest of this is IP connectivity through the private network, ultimately to pull an IP address from this point. From here on out, I want you to understand something. This is very important you understand this. Wherever you are in this private network, to the rest of the world, you're here. Just stop and ponder that for a minute. If you're right here, that's where your phone is, and you connect through the network, you don't realize that's happening to this point, and then you continue on surfing the internet. To the internet, you are right there. There's nobody has any notion of where you actually are in this. Very important you understand that. So, well, then what would make sense? And I'm thinking, well, what would make sense is if I'd be right here, then I want to use that as my point. I want this to be as short as possible so that the distance from my UE to the user plane function be right next to each other, like 20 kilometers apart. But let's continue. What if we create another one of these? And this one we're going to put in the Florida Panhandle. So we have one in central Pennsylvania, which is where I live, right near Hershey, Hershey Park, Hershey Kisses, all that stuff. That's right near where I live. And down here, we just put one in the Florida Panhandle because that's a nice part of the country too. All right, so we have two places like this. And let's start with that as a practical scenario of how all this works. Oh, yes. Before you ask, because I would if I were taking this, is there more than just two of these? Yes, hundreds and hundreds. As many as you want is what they can be. And they can actually be private destinations if you want. That's what gets cool about slicing. As many of these as you want effectively artificial intelligence to gen up. As long as our underlying network, if I flip back, as long as this underlying network actually has the physical connectivity to where we need to go, we will build a network on the network. As Exhibit would say, I heard you like networking. So I'm going to put a network on the network so you can network while we network. That's actually what's happening. In all honesty, that's what happens in 4G. But 5G does it in an incredibly automated fashion. So there is seemingly limitless amounts of networks we can put on top of this network. Let's keep charging. Now, here's where we get a little technical. I want you to imagine that this /16, so this is a range of IP addresses. Here's a public range, actually is part of this, I'm going to say the word now, data network, which is a constituent of a slice. So I'm feeling right now, if I call this a slice, that needs to be okay with you. And inside of this slice, I have this data network. It's very graphic. Notice that the underlying network, that IP network that I was talking about, I made that go away because I want you to think, okay, it's there, but I don't need to see that anymore because we're going to build a network on top of that network. So we just fade it into the woodwork. We know it's there, and we know that we have edge points now that we're going to connect into that, which means I could have a phone right here. That's your UE, your user equipment, and it's in on the Florida Panhandle. And notice the different IP address. Well, of course it's going to be. So this is where the notion of slicing comes in, or at least the beginning of it. There's your phone. And it's minding its own business somewhere in the Florida Panhandle. We know that 60.60 exists here and 60.61 exists here. Now, if we're going to put the computers in charge of this, which is what we want to do, then we have to add some additional abstraction. We have to identify this slice. And this is where two very important numbers come in. The slice service type and the slice service type is going to describe, think of it as like a identification of the kind of service that you want, the kind of quality that you want, the behavior of the network you want. And right now, it is mandatory that you understand there are four. Because again, in the discussion of this in a very practical way, you can actually have four different kinds of slices. Let's go right down through them. The number one slice, which will be by far the most popular, is enhanced mobile broadband. That's code name for really, really, really fast 4G. That's what that is. That's, I want to access at a gigabit per second with like 10 milliseconds of latency, like everything good. That's just incredible. Oh, maybe you want slice type number two. Now we see that this is slice one down here. And by the way, up here where I live, there's a slice one as well. So we would say then both of these slices are of type one, which we've defined as really, really, really fast version of what would be the way we surf 4G now. But there's some additional slices that 4G doesn't have, like ultra reliable low latency. What that means is my connectivity from wherever I am to wherever I'm going needs to be a millisecond or less. Well, okay, laws of physics say that this would now be impossible, which means that my world, the place that I can connect, practically speaking, is restricted to like there. If you cross that line, you have a speed of light constraint. Forget it. So that means if I'm calculating what networks you can go to and you're asking for a slice type of number two, then practically speaking, you got to stay inside that circle. Let's continue. Number four, massive Internet of Things. Okay. If I am this type, which is not a phone, then I am a integrated circuit chip. I cost about 75 cents. If you connect to me to a battery, I will last like 10 years. 56K is blazing fast to me. And I want to be connected to things that I only have to send a few bits. If you have to do a firmware update to me, well, good luck. It's going to take a while. And by the way, I really would like to go a little faster when I need to. And I'm okay to give up some of my battery life for that firmware update. But for the most part, I'm living in the world of what's the temperature outside or how much electricity have I used? Is this valve on or is this valve off? Something like that. That's slice three. And number four, the vehicle to vehicle or vehicle to anything. That's the real hot one when everyone's talking about that. That would be associated with your car. So that's vehicle to pedestrian, vehicle to the city, like for fire trucks driving down the road, turning the lights green as they go down through the, that sort of thing. But how about slices 5 to 255? They continue. There's more than just four. They're not defined yet. So we're not going to worry about them. So we're always going to see this slice service type. But what is interesting is in the practical discussion is that that's not interesting to us. This slice descriptor is far more interesting. It's never explained to any degree, which is part of the reason why I said, okay, I'm going to do a webinar on exactly this. And I'm going to just demystify what we're actually going on here. Because ultimately, the problem we are trying to solve, algorithmically speaking, is if I know the longitude and latitude of a phone, of a UE, how do I know which slice I could actually connect it to? Well, unless I come up with a way to identify the different slices, I can't. Well, we know that computers love numbers. They just love them. So now what I'm going to do is I'm going to say, I'm going to create a slice number one, and up here, I'm going to create a slice number one as well. Well, that's great, but I can't distinguish between those two that way. So I need a slice descriptor, which I arbitrarily decided 112233, and up here it's totally arbitrary, 010203. Okay, so then if I put these two together, that would uniquely describe this slice. Now, it's important you understand that this would also be associated with the public land mobile radio network identity, which means the mobile country code and the mobile service provider. Those two numbers go together with this to uniquely identify this slice on the planet. Underneath that slice will be assigned what used to be a 4G APN, what used to be a data network name, which we all know what the internet is. So I'm saying part of this slice right here means that you can connect to the internet. Right now, I'd be very tempted to say, what if you want your cool private? What if I want a DNN to equal my cool private slice that no one else can get to? Well, we can totally do it. Absolutely can do it. It's not even hard. What will be interesting to watch how this gets monetized, because 5G definitely likes solving that kind of a problem. Right now, I'm saying I'm only running this one data network name underneath this slice. And you'll notice down here, why did I keep the same name? Think about that. What do you mean the internet? Well, actually, if I change the name, that just totally breaks everything. Because my phone knows it wants to connect to the internet. It doesn't have to know what slice it's in, although it will. It doesn't need to know that. It just needs to know I want to get to the internet. And if you're of slice type number 2, then we can't even consider this slice. It's too far away. In fact, if this phone needs an IP address to do ultra reliable low latency, the only one that's going to work is the one right here in the Florida Panhandle. See how that works? So what would have to happen is we'd have to algorithmically calculate what is the longitude and latitude of the phone, what's the longitude and latitude of all the slices like on the planet, and describe this one's the closest. And you could realize how quickly that search could be made in the hands of a good code writer. Obviously, the answer is, if this phone wants to surf the internet, then it should go to slice type number 1, 112223, not up here. So let's illustrate that. There we notice are the two slices. They're both enhanced mobile broadband. We observe they both have internet. So both those services are available there. But these data network names have different slice descriptors. This is for the artificial intelligence, the part that theoretically you don't need to know anything about. But I think in a practical sense, you do need to understand this if you're going to understand ultimately how we can use this. So we continued charging and said, well, if my phone is here, should I choose SST1 slice descriptor 0102? Should I? You know, it'll totally work. It'll work okay, not great, because what will happen is your phone across that private network, I'm not showing you the private network, we know it's there, will tunnel using GPRS tunneling protocol. The mechanism's unimportant, but it will tunnel to there and it will pull an IP address from this point, which means that if we surf a website, which is down here, every single message we sent, I guarantee will follow that path. And that is unfortunately all too common in 4G networks. But if we put the machines in charge, if we let big data and artificial intelligence and actually some fairly straightforward algorithms in charge, there's no way we're going to choose that slice. No way. There's one that's right here. This is better. You'll have no idea why your phone surfs so much faster, but it does, because there's an aspect of surfing that you don't think about. It's called latency. When you click, if you get the result coming back at you before your finger compresses fully on the glass, I want you to imagine how fast a millisecond is. As you're touching the glass, you're getting the answer. You're not used to that because it is not uncommon, especially if you have a phone number from far, far away, that your home network is back here. And phone companies didn't have any problem backhauling traffic all over the place like that. Didn't bother them at all because you're only accessing at these incredibly slow speeds, like 40 megs. Can you believe I'm even talking like this? 40 megs. It's laughable. We want to connect at a gig now. Well, we don't. Okay. Phone companies are not interested in backing hauling a gig. Even if that underlying network is running at terabit speeds, I mean, holistically, backhauling at that rate just doesn't make sense. So we're going to put the machines in charge. And this is the nature of slicing. But we're not quite done. We need to go backwards a little bit and actually analyze what just happened here. So let's hop back to this point. And we've been talking about this internet. Remember that? This data network name, internet? For a lot of us, that might be all you need. If all you do is surf, if your voice is going right over the top, rather than through IP multimedia subsystem or something like that, maybe the internet is all you would ever use your phone for. But generally speaking, there are 3 additional data network names, at least, that would be supplied. One would be IP multimedia subsystem. So that's fancy name for saying voice services using session initiation protocol and session description protocol and RTP. It's a wonderful system that actually was put in place in the 4G era, and it follows through to 5G. So this particular slice certainly could have a DNN, which equals IMS. Most likely that could be a different slice, but you could put all of these underneath this slice. Let's continue. The SOS, save our ship, dialing 911. If you don't pay your phone bill, maybe you don't get the internet, maybe you don't get the IMS, but you will get the ability to dial 911, no matter what. Lastly, the admin. This is super important. You may not think so, but let me convince you. Your phone, that little supercomputer you have in your pocket, needs its software updated periodically. You don't want updates to come from untrusted sources. So this deserves to have its own data network name to supply firmware updates to your phone. Therefore, let's put it on its own data network name. Let's verify that we're absolutely connecting just to that. So the phone, unless you root your phone, will insist on that to obtain its updates. I mean, I quit rooting my phone a long time ago. I did when it was the cool thing to do, not anymore, right? But in the practical sense then, do we have to start with or stop with just 4? Oh no. That's where this gets really interesting. Do you want to add another data network name for like global knowledge? So maybe global knowledge decides we want our own network on top of this network. We don't want anyone else to access it because it's just going to be for our sales staff, for instance. And running a VPN is hard. And if we did it this way, then we could just say GKN, VPN, whatever. And as long as we create an IPsec connection into this network, a phone could request a connection to this, and the 5G network would build it almost instantly. It would laugh at how easy that would be for it to do that. What's particularly interesting about this is that this would apply to any one of your networks, and it makes you rethink the whole notion of VPN. If this is priced properly, this is going to dominate access for mobile personnel because it creates what we like to refer to as a zero trust network. You don't get on this unless the network lets you. You don't get to connect to anything unless the network inspects where you're going to. It's really wonderful that way. And that's what's really compelling. And because this doesn't run over the public internet, this runs over the phone company's private network, which, by the way, can interconnect with other phone companies' networks to achieve what is effectively a VPN over dedicated hardware. All right, so let's continue with that. So we see how the slices makes connectivity managed. Well, okay, you should be thinking, but what if I'm here? What if I'm somewhere in the mountains in North Carolina? Well, then you don't want these slices, do you? You would want the one that's nearest to where you are. And I literally threw a number down. It's completely arbitrary, 7788, whatever that was. And of course, I had to use the same DNN name because your UE knows, oh, I want to connect to this particular DNN. Now, there's more to the configuration than just this. And that's where I want to show you in a little demo how cool that can get. You can actually specify a whole lot of rules against what you're allowed to do against this DNN, which belongs to, yeah, it belongs to that slice. This is where it gets interesting. Just think about it right now. Does the DNN internet belong to just one slice? I'm hoping the answer is immediately apparent, right? No, it's all over the place. Oh my gosh, that means if I have these little slices all over the place, the network all sliced up like this, I have to configure this on every single one of those? Yes, positively, but you don't have to. And guess what? No human being is ever going to do that. This is where the machines come in. It's all database driven and orchestration driven, but it is far from trivial in the rollout of all of this. But when you put the orchestration component in place that can populate slices all over the place, you have the ability to build this network on top of the private IP network and make things incredibly secure, especially if it's done well. I find the whole idea really cool. And the question is no longer that really of market or of engineering. It's more of how do we market this? This has great potential. All right, so let me actually show you an example of configuration that we do in class. So when we teach this, we actually teach using real 5G components. So in fact, if I just drop down into the OSS, just to give you a quick tour here, we have a 5G core, 5G G-Node B. I know there normally would be thousands of G-Node Bs. In this class, you get one. And the 5G web, the 5G phone itself, the UE, of course, which we emulate. That's emulation software. And then the 5G user interface, which is this. The only problem is this is kind of small if you're watching this on your small screen. So I actually have this full screen over here. And I've logged in already and hope, unless I timed out, which could have happened. Let's click the modification on this. And what I'm going to do now is show you how to edit a subscriber. And I'm going to walk down through this to kind of get you the context of the thing. And then we're going to call it. That'll be it. That's our goal. So let's start out with this part right here, guys. Look, I'm going to stay above that slice information. This is what you're waiting to hear me talk about, but let's take it in context. This is the stuff that would be burned onto your 5G SIM card. So, and the deal is whatever's on the 5G SIM card, which is plugged into your phone, has to match the connectivity on the network. You're not looking at the SIM card right now. You're looking at the 5G core. So this is the information that's stored in the 5G network about your phone. So you'd have to imagine that you have a public land mobile radio network ID. If you look this up, you'll see that 208 is actually France and 93 is contrived. that's a mobile subscriber that does, or a mobile service company that doesn't exist. Then we see the SUPI, or the subscriber permanent identity, which is the 5G version of the 4G MZ. We rename everything. Why? So the international mobile subscriber identity, the new cool thing to say now is SUPI. The authentication method, you'll recognize that. That's identical to 4G. And if you don't, it's fine. We don't need to know that. The key. Now, obviously, this is no longer very secure. I just show you, but I don't really care. This isn't a real phone. But one thing's for sure, the emulation phone that we use to do our labs in this class wouldn't work unless we precisely got that right. And the operator code, and we described the authentication mechanism to ultimately connect the phone is covered in the class, but it's not relevant to this discussion. Then what is relevant? Well, that's we connect into the practical part of the discussion, like show me this. So here we go. Watch, check out the power of this. This is like crazy. So here we can define this particular phone, Slice Service Type 1. I can, if I want, supply a Slice descriptor. Now, if I put all Fs, it's important you understand this. If I would actually need, it's 3 bytes. If I put all Fs there, it means I don't care, which means let the machines choose. But if I do care, if I want to force, do you remember that 01, 02, 03? That was either the Florida Panhandle or that was Hershey, right? All right, if we're going to specify that, which we can do, and in class we set it up this way, then regarding this particular slice, what exactly can I control? All right, well, we're just going to take a look at 2 of them because that's what I can fit on the screen. So we see, well, all right, here is that data network name. Oh yeah, the DNN. There's the internet one. Oh, here's another DNN that's on the same slice, and this is IMS. Oh, this is interesting. You mean I can throttle this guy? So if this guy wants to connect to the internet, I'm going to let him surf at 200 megabits a second. Really? That's how that's done. Oh, wait a minute. He can uplink at 200, but only downlink at 100? Look, I totally made this up. I can type in whatever I want. So can the phone company. But the aggregate maximum bit rate is shown here that I can control this. And the quality control, I'd have to look that number up, but ultimately that number means how I would treat this traffic relative to packet loss and retransmission, all that stuff. But wait, in this particular slice, I believe that was in the Panhandle, but if it isn't, forgive me. Looks like we have another data network name in there, the IMS. And wow, this is some really big numbers for the IMS. And by the way, all I'd have to do is click plus, and I could add more rules, or I could add more networks. I didn't because I wanted to keep it sort of grounded in reality. But while we're at it, what if we imagined that this was, you know what, I'm just going to give the global network guys their own dedicated network, which I could do. But if I'm going to do that, and I have to do some configuration elsewhere in the network, but just to see the power of it on a per phone basis, I can click the flow rules. And in here, I can filter on destination IP address that they're allowed to, the quality control index, the uplink and downlink guaranteed bit rate, the uplink and downlink maximum bit rates for this particular service. So I can control this on a per phone basis for every single subscriber on the network. So you can imagine how you could monetize that. And in fact, you should be imagining, wow, I actually should be talking to my phone company about rethinking VPN access for all of my mobile people. because this certainly would solve that, right? I'm not going to go ahead and save it. You get the idea, but we would continue. And this is where the list gets really long. If I'm going to allow my phone on lots and lots of slices, then here in the central point, I'm going to say, yep. And he's allowed to access this slice as well. And if he's there, then here's his rules. And I stopped it right there because it's only an hour presentation. But this list could go on and on and on if we'd want it to. In fact, we could push new slices on the fly if we'd want to. All right, so I'll tell you what, I'm going to leave it at that. That just gives you an idea of how the phone company can configure access on a per subscriber basis, which you saw. I just literally went into this particular user and did that. On our network, we only have one user, so we're not generating a lot of revenue on this particular example, but I think you get the idea. Okay, so that being said, the part that I'm just going to talk through and not demo is in any decent network of just supplying basic service, we would have to describe internet access because everybody wants to surf, and you'd have to do that per slice. A data network name for IP multimedia subsystem, that's for the voice traffic, for the 911 traffic. And I only did this graphic so you could see that this is not easy. This isn't something that we want a human being to have to do. So enter the world of microservices, of orchestration, and things that we're going to get really good at. In fact, that we already are getting really good at in 5G. And ultimately, this is the basically the red carpet for 6G, where scary, amazing stuff happens. This is laying all the groundwork for it. And so what you have to understand is all the work that was done on this particular slice needs to be repeated for all the other slices the whole way across the continent, wherever it is that a phone company or some service would be offered. And if you were to say, you know what, I want my own personal slice, that's my company right there, that's me. And no matter where my phone is, I just want to add another bullet right here that basically says, I want to go to there. You can totally do that with 5G. It's designed to do that and to do it almost instantly. And then if you could say, regardless of the slice, if you don't care about the slice descriptor, then it's FF, right? Which you would, because you would say this particular slice, which is that one. Because you think about it, no matter where you are on the planet, if you're coming to your company and your company's right here, then that's where you have to come to. So I would just have that one slice entry for anyone who works right there. And now you have your own private network riding on top of the 5G network. It's super cool. All right, so the notes then on what I went over, this is simply a review. I actually took you down through all of this stuff. I showed you an example of how to configure the subscriber and how the trust relationship is maintained. You don't get on this network until you can, unless your phone can supply this information. Once that information is supplied, we are able to connect the phone to multiple DNNs, where in my example, I made all of these DNNs available through the same slice. I don't know if you noticed that, but that's what I did. I'll prove it to you. If I went back to this, all these DNNs, which I can totally do, I put it underneath that slice. I didn't have to. If I only am running the IMS, maybe I have IMS services like this around the network, then depending on where you are, I would request the IMS slice that's closest. So how many was that? 1, 2, 3, 4. I don't know why I'd be up in North Dakota, but whatever. It's because there was room for it. That would be, there'd be 6 IMS slices, which means we'd have to define them. Yeah, we would have to define it. The machines would have to orchestrate all of this. but it is possible to run all of that inside of one slice if you'd want to. Regardless, the phone doesn't care. It doesn't have to know all of that. It will be able to access as many of these data network names as you want to. There's really no limit on data network names. The number of slices, I think it's 8, guys. I think you can have up to 8 slices, which feels like 2 more than any phone would ever really need. I mean, 6 more than any phone would ever really need. But truth is, 8 slices should be plenty, because typically many of these slices can exist, or many of these data network names can exist on the same slice. The other thing you should have noticed from this is that you define the slices associated with an IP address, with a subnet. You then assign data network names to the slice, and you'd be extremely redundant there, where if you have an internet data network name, you're going to be installing one of those in every single slice that leads to the internet. All right, there you go. I believe that actually takes us right to the end. And let's turn this back over to questions.
Yeah, absolutely. Thanks, Stu, and thanks for your expertise and the demonstration there. So we do have the ability to ask some questions in the remaining time we have here. We do have a few questions already queued up, so I'll start with the first one. The question is 5G all about phone? How can it help us in our traditional network? Fiber is expensive. We use PTP wireless for temporary solutions. Do you think 5G can help in this context?
Yeah, and especially 6G will. So 5G is where you start to get your feet wet, and that is you are now asking the right question. So yes, you would have to consider where the 5G connectivity makes sense. But wireless connectivity is really easy to deploy. It's incredible as a backup, and the ability to deploy fixed mobile. So that simply means a 5G device that doesn't move around, which, by the way, they become extremely efficient. If we don't have to support mobility, then you can define that in the slice. Bigger and beefier antennas, you don't care about battery because it's plugged in at that point. And that becomes incredibly compelling. So the only thing that's going to slow you down there is as phone companies roll this out, the marketing issue. But what I've gone through as far as the technical concerns are, that I was almost a slice of cake. That would be a piece of cake to do that. You definitely need to ask those questions to any carrier that interests you. They can do that right now. Well, what's the other question?
Awesome. So the next question is, this technology is awesome, but does it come with a trade-off for the user? How do we safeguard against exploiting all this data and monetizing it without the user's knowledge?
So the idea is that in the perfect scenario, it's the phone company's network. Now, if you don't trust the phone company to be able to run a secure network, then yeah, that becomes an issue. But my opinion on that is that they're really good at that. Phone companies are really good at that because they live in that world all the time. So that by using their network to build your slice on top of it, how do you get into that slice? Well, the only way is with a SIM card. Even if your device is not mobile, if the device is fixed, it still takes a SIM. And access to the network is now all encrypted in 5G. The IMSI is not sent up in plain text. So access is actually more controlled in 5G. So I think that this is actually more compelling from a secure perspective, because 5G is the first type of networks that could actually offer zero trust connectivity. It's the only network I've ever seen that could actually do that. So what I would suggest, because that's a very good question, is to study up on what zero trust means. There's a lot of YouTube links and things out there that will explain that. And then understand that 5G has the ability to deliver that actually on a global scale. What's the next question?
Awesome. Thanks for those questions. As of right now, that's all that's in the queue. So we still have a little bit of time left. If those want to ask additional questions, please go ahead and insert that into the Q&A. But for right now, Stu, you can go to the next slide and we can explain a little bit about the portfolio for 5G training. So if you guys are interested in learning more, we do have a pathway for you. So the first class, 5G overview, it's coming soon. It's coming very soon, actually. It's a non-technical, high-level overview class. It's about half day in duration. So that's going to be there just to go over the concepts. So if someone's not needing the hands-on approach, that's a great class to take up. However, if you are interested in kind of what the demo that Stu ran through the demo today, the 5G Essentials class is perfect for you. It allows you to get your hands on, and if you're taking an active role working with 5G engineers, that's the right class for you. And in addition to that, if you have a responsibility to deploy 5G, we have a class coming very soon that's going to take a hands-on approach as well. And it's going to allow you to understand how to deploy a 5G network at scale. So, Sue, I don't know if you want to dive into any more of those two classes, but feel free to chime in with any color.
Yeah, sure. So you can't take the 2-day class without the 3. I'll warn you that right now. So the 3-day class is going to put hands on. You'll configure all this stuff on a real 5G network that I've just described, and then the 2 days after that is you're going to take all of the microservices, containerize them, put them into a Kubernetes cloud, launch it on a Kubernetes cloud, and basically take it to scale. So the advantage of this is that normally that would be 5 days where, that would take normally a Kubernetes boot camp to understand this. But if your scope is just 5G, then that allows us to take a lot of shortcuts in the training and get all of this done in 1 week. So that's very compelling for some people. Yep. Back to you, Kevin.
Yeah, absolutely. So as Stu mentioned, there are complementary skills that you would need in a 5G environment. So we have classes that cover microservices, Kubernetes, SDN, NFV, and SD-WAN. So we feel very confident. We've been delivering these classes for quite some time, and we've received a lot of great feedback. So we definitely welcome you joining some of our classes. So take a look at the full course outlines on our website. And if you have any questions, please reach out to your account executive. Before we move on to the next slide, Stu, we do have some questions that did pop up.
Sure.
So David H asked, are we at a point where all this user data is considered personally identifiable, so PII?
Well, it definitely is. But understand it's not personally identifiable to anyone just walking around with some electronics on their back like you can do with 5G or 4G. In 4G, I can sniff right out of the air who's around me. The box that's used is called a stingray. So in fact, you should Google that and understand what a stingray is. It's very intriguing. Basically, just walk around with a laptop in your backpack and a $1,200 antenna array, which no one knows, and you can find out everyone around you, all their identities. You want to see who's going in and out of certain buildings? That certainly would do it. That is impossible with 5G. You can't tell who anyone is around you. But that doesn't mean the phone company can't. They certainly can. So as far as connectivity is concerned, if you are concerned of the phone company reading your mail, as the case may be, there is no substitute for end-to-end encryption. So that person is correct in that if you want to keep your connections private, that is from the phone company, you still have to do end-to-end encryption. You don't get out of that. But can anybody connect to the network that you're running? No, only the rest of your company that set it up, and of course the phone company. No one else gets in. So this is basically a ironclad, a strong brick wall against someone else watching what's going on in your network. But it is not a brick wall from the phone company watching what they could see everything that's going on. To protect yourself against that, you need end-to-end encryption, and then all they see are bits. They're otherwise meaningless. Yeah, it was a
Awesome.
good question.
Yep, thank you. So if you want to go to the next slide. So if you have additional questions, please reach out to your Global Knowledge account executive. You can also reach us on social media via these handles. And the following slide is if you would like to access this recording, we'll send it to you via email, but this will also be posted on our website, along with other on-demand live webinars, white papers, courses, special offers, and more. Visit globalknowledge.com, and we have a whole host of resources for you. So Stu, I want to take this opportunity to say thank you again for your expertise. The demonstration was great. So again, if there's no further questions, I think we can wrap up today's webinar. Everyone have a great day, and we'll hope to see you again in a Global Knowledge class soon.